Hello everyone, my name is Jeremy Davis. For those of you who've not met me before, I am a developer and consultant here at Kaggle. And when I came to work here about 18 months ago, I had never used Solr before. Slightly embarrassing admission, but it's true. So I had a pretty sharp learning curve with getting used to that. So far, my learning curve has brought you the PowerShell scripts that I wrote for installing simple developer instances automatically to make your coding life easier. But recently I needed to get Solr and Sitecore singing together in production like operatic tenors, hence the terrible pun, and I found the documentation for production a bit confusing. So tonight I am going to very rapidly run through basically the minimum you need to do to get an on-premise production type Solr install to work. It's quite a lot to cover, so I'm going to kind of power through this. And if you've got questions, you probably will have questions because I'm sure I'll miss something, I'll take them at the end. Okay? Awesome. You're not an American audience, are you? So let's start with why production needs a different type of install. And there's basically one key reason, and that is resilience. As time has gone on, more and more of Sitecore has come to depend on search, and on Solr in this case. So if Solr breaks, a lot of stuff potentially stops working, and that's pretty bad for a production site. So Sitecore say we should use Solr Cloud instead of the simple developer setup. That's basically a cluster of Solr servers. It's the same search engine, but it's put together in a way that means it can cope with things breaking, and it can scale better to deal with larger loads. It combines the Solr you know and love with a service called Zookeeper, whose job is basically just synchronizing data around this cluster. And what basically happens with all of that is that you start with a group of so many Solr servers that can all share the work of indexing and querying. And they're all connected to instances of Zookeeper. And all of those instances know about each other, so they can talk and share configuration and work out who's up and who's down. And then Solr sits behind some form of load balancing to share out traffic. So in theory, any working server you've got can answer any query that comes in. And that means Solr and Zookeeper instances can fail without disrupting your actual website. But as a side effect, more complicated diagram, more complicated setup. And the first step is that we're going to need some servers. If you need a cluster to survive n of your servers breaking, then you need 2n plus 1, according to the documentation. So the bare minimum is 3 boxes to run a resilient cluster. The documentation does kind of suggest that you're supposed to put Zookeeper on different hardware to Solr, but I think the reality is that it's very difficult to justify 6 servers for a small setup. So in reality, most people are probably putting one copy of Solr and 1 copy of Zookeeper on each of their boxes. How big are the servers? That's a bit trickier. There isn't really an easy formula here. The official advice is basically guess and measure and see whether you made a good guess or not. The bottlenecks for this sort of processing are likely to be how much memory you've got for caching data and how fast your disk can push data backwards and forwards for indexing and for reading queries that aren't in memory. These days, disk is pretty easy. For the most part, I think if you use SSDs, you're probably all right here. Memory is a bit trickier. The best memory size for any particular deployment is dependent on lots of factors. And if you look in Google, there's a really complicated formula, basically, that takes loads of parameters about what you're doing with Solr and tells you how much memory you need. But to be honest, my usual shortcut is stick 16 gig on the box and measure it and see if that's enough. Because memory's not too expensive these days. And you probably want about 8 CPU cores because there's going to be various parallel threads of operation going on. That's a starting point anyway. So with Kit in place, your next problem is you're going to need Java. Ideally, you need the latest version of the 1.8 Java runtime. You can use newer versions, but you're going to need to Google some extra config steps because it doesn't work quite so simply. You're going to want the 64-bit version of Java to allow for lots of memory, and you need the server build for efficiency, apparently. The simplest place to get all of that, in theory, is Oracle's website. but they have made our lives more difficult with this business about, laser pointers don't work on these today, this business about paid licensing. So alternatively, you can use OpenJDK. You can get that from GitHub, but the URL for downloading it is not exactly memorable. Google will help you out though. But just download the one you prefer, and you get an archive, which inside it has a folder called JRE. And that's the thing that you need to drop on each of your target machines. When you've done that, the easiest way to make sure everything can find Java is to create a Java_home system environment variable on each machine that just points at this JRE folder that you've created. Then you can head over to Zookeeper and grab the latest version that's supported by Solr. I believe that's 3.4.14 at the moment. And then you're just extracting that onto each of your machines. But there are two important things that you have to do each time you extract it to set it up. The first is that you need to create a data folder on each of your instances, and you have to put a single file in that called myID with no extension. You are putting basically a single integer in that file, the instance number of this copy of Zookeeper. Nothing else goes here, and no two machines in your cluster can have the same number. And then secondly, you need to create the main Zookeeper config file. You name that zoo.cfg and stick it in the conf folder. And at the minimum, there are 4 important sets of things that go in this file so that Zookeeper will start. First couple of lines are timeouts to do with starting up and getting back in sync when data changes. Basically, that's how long it waits before it decides something is broken. Next, you need to tell it where it's going to save its data, and that's that data folder you created a few minutes ago. The double backslashes in this path look weird to Windows users, but it didn't seem to work for me without them, so I think that's possibly a side effect of this being Java software running on Windows. Then you need a client port where things are going to connect in order to talk to Zookeeper. You can use anything, as long as the port's free, that's fine. And finally, you have to tell Zookeeper what set of servers are synchronizing. So you need a set of lines with this format for each machine that you've got in your cluster. The numbers at the beginning have to match what you put in the myID files, and then you have to give it a host name, and you'd probably use real names, but I just happened to nick this off a box where everything was running, 3 instances were running on the same machine. And then you have to give it each one 2 extra ports that get used for the leadership election to decide who's in charge, for detecting uptime, and for actually pushing data backwards and forwards across the cluster. And again, any free ports are going to work. And once you've saved that, you can start Zookeeper. There is a zkserver.cmd file that sits in the bin directory on each machine, and you just run that. For production, you're probably going to want that as a service, so you'd set it up with something like NSSM or an equivalent service manager. And you can move on to Solr. You start by downloading the right version again, based on what version of Sitecore you're installing, and you unzip it. And you're going to need HTTPS, because Sitecore likes everything to be secure these days. Any certificate that Sitecore will trust will work, but it needs to validate the names of each instance of Solr you're running and the load balance name that Sitecore is going to talk to. I only had serial host names, but you get the idea that you need that all in the certificate. And you're going to need to save that file probably as a PFX file. You can do stuff with Java certificate containers, but I find that very difficult to work with on Windows. PFX is easier for Windows installs. But you need it in that file so that Solr can load it when it starts up. And with that in place, you just need to configure each of your instances of Solr. There's a file called solr.in.cmd that exists in the bin folder of each of these instances. And you just have to remove some comments and set some values in there. There's an option, this is probably a bit difficult to read at the back, sorry, I was hoping for a bigger screen than this. But there's the first one is Solr Java mem, which is telling some flags to say how much memory Solr should use. You need to tune that to fit how much memory you've actually put on your servers. Then there's the zk_host variable, which is basically the connection string for Zookeeper. It's a comma-separated list, and it's Zookeeper hostname : Zookeeper client port, and you need to put each of the instances of Zookeeper you're running in that list. There's a Solr host variable as well, which is the name that Solr is going to identify itself to Zookeeper with. It needs to resolve correctly to the current instance of Zookeeper so that the conversation can go backwards and forwards correctly, not the load balanced address. And then you need to uncomment the Solr port thing to say what port you want Solr to listen on. And then there's 4 settings where you tell it what your SSL certificate is or what the password for getting at the private keys are. Though that bit is exactly the same as setting up a dev instance. Now, importantly, before you actually start trying to do anything, you need to tell Zookeeper that it's going to speak to Solr under SSL. To do that, there's a little tool called zk-CLI. But, danger point, that tool exists in both the Solr and Zookeeper install folders when you unzip it like this. You need, to make your life easy, if you're following the documentation, you need to use the one that Solr provided because it's got some slightly different options. So you run the zk-CLI.bat in the Solr Cloud Scripts folder. It's quite well hidden. And you pass it that connection string for Zookeeper, a little instruction to say, I want you to write a property to all the servers on the cluster, and you pass the property URL scheme and the value HTTPS to say, please talk using the certificates we're providing. When it completes, you can then start Solr with solr.cmd, the usual way. You pass -f for run in the foreground and -c to turn on the Solr Cloud features, and you set that up as a service. And with that, the admin UI will start up, and you can do whatever you're going to do with load balancing. I'm going to skip over that because I don't have time to talk about it, I'm afraid. But you will notice probably that there are a couple of extra options hiding here. There is this cloud menu option, which lets you get at various things that tell you about the state of your cluster. And some options to do with collections have appeared on top of the standard stuff about cores. And these are an important point in themselves. In development, we're used to managing cores in Solr, basically what Solr calls the kind of wrapper for chunks of index data. Solr Cloud spreads its data across multiple servers. It can do replication, where it puts a complete copy of the data on lots of servers, and it can do sharding, where it puts a fragment of the data on different servers. And those help you deal with the reliability and with scaling. And you can also mix and match those things. But what that means is that cores under the surface get odd names and unpredictable locations across your cluster. So collections exist to abstract away that complexity, so you don't have to care about that. A little side note, if you plan to use switch on rebuild settings in Sitecore with your indexes, you need to create some aliases and some extra collections for rebuilds, but the Sitecore documentation is all right about setting that up, so I would just Google that one. And annoying issue at this point is that the Sitecore install framework doesn't cope with doing any of the setup of collections at the moment. It knows about writing cores, but it doesn't know about how to set up a collection, so you have to do it yourself. To do that, there's a couple of jobs that need to happen. You need to push some schema config up to Solr. I find it easiest to steal the config from a developer instance. There are instructions on Sitecore's website for doing it by editing the config that Solr ships. I find that weirdly unreliable. So I tend to go and open a couple of core folders on a developer instance and steal one that's a content index and one that's an Xconnect index, because in each of those folders there is a folder called conf, which has got the data you need in it. So you can squirrel those away safely and upload them to Zookeeper with the solr.cmd command again. It doesn't matter which of your instances you use to do this, but you pass the zk-upconfig command to solr.cmd to say, I want to upload some config to Solr, and you tell it where that config is coming from with -d, and what you want it called in the UI with -n, and then there's that Zookeeper connection string business again. Quick tip here, avoid spaces in these paths. It seems to break some of the scripting around Solar. And once that completes, you can see the config in the UI. And from this point, you can just use the Add Collection button up here to manually create all of the collections that you need with the same names as the ones that Sitecore would create as cores on a developer install. The only thing that's different here is that you have to remember that I've obscured it in the screenshot annoyingly, but there's an option for replication factor. You just have to set that to the same number of machines you've got so that it replicates across your cluster. I have to say, I find it easiest to script this stage. Solar has a nice REST API for creating collections and aliases easily. The documentation's all for version 6.6, but it still works for the newer versions. Either way, once you've created all of those, what you should end up with when you look at the kind of the status of your cloud is each of your collections is spread across each of the servers that you've created, and one of them is in charge of that particular collection. And at that point, you're basically ready to deploy Sitecore and point it at your load balanced Solar address. What you do have to remember is after CIF has installed, before you run CIF to install Sitecore, remove the bits that try to create Solar cores, because it can't do that in this instance. And after it completes, you need to edit the connection strings on any machines that have the Solar connection string to put semicolon Solar cloud equals true on the end of the URL for Solar. I can show you little bits of that working very quickly before I finish. I've tried to condense all the stuff I've said into a little PowerShell script that goes through the process. Apologies, the video compression goes a little bit weird in a few places here, but it's doing exactly the same thing I talked about. It's starting off by unzipping a copy of the Java development kit, and then it's going through creating instances of Zookeeper. I wrote this bit of script so that it will create an instance of Zookeeper, configure it, then create another one and configure it, because I wanted to put 3 instances on the same machine. But I was kind of working this out for the purposes of doing it for client deployments in the future. And then it will start Zookeeper, and you can see they all start throwing out some nasty debug output, but basically they just have a little election and say who's in charge, and then they sit there waiting for something to do. So then Solar can get installed, and again it's just a point of unzipping the copies of Solar and writing those bits, those configuration changes. And once it's got through doing 3 of those, it needs to start up those instances, and get another couple of windows pop up. It's pushing out the config to tell Zookeeper to run under SSL, though you don't really see the window for that here. There is a third Solar window that's kind of in the background, but you get a bit of debug output, and probably in a second some more weird image compression on my video. But once the 3 instances of Solar have come up, the script can then push up the configuration for the cores under the surface, and then go through the process of just creating all the indexes and all the aliases automatically. All that scrolls past. And once it's, and this is also going from the perspective of using swap and rebuild for everything. But once that's finished, you can start the admin interface. You will see when I click through to the logs, this video could have gone 10% faster. There aren't any errors here. There is one warning about a depreciated analysis class. I think that's down to Sitecore's configuration. And when you look at the set of collections, they're all happy. But we can prove that the resilience is actually working. So all these are green. I will kill number 3. So you'll see when that process gets stopped, I'll just shut the window, I can refresh this, and you'll see that all the number 3 instances, if that's the one I shut, all go grayed out. Zookeeper knows it's gone away, and in the places where number 3 was in charge, it's quickly pushed the ownership to a different one, so queries would keep working, your site keeps running, and when you get that instance back up, everything would be happy again, which is a big win. So, enough of my very fast talking. Very brief summary. There is a bit more to do to make this work. But actually, it's not enormously complicated once you get your head around the process you have to go through. And I do plan to try and release some of this script I've been working on later in the year as a kind of production version of the stuff I wrote for developers. But that is all I have to say, and I am happy to take any questions if I haven't completely bamboozled you all. Which I think I have.
I've got one. So I've only done this once a few years back, and I'd imagine things have moved on a little bit, but most of what you're saying there kind of reminds me of some of the things I did. But one thing I remember happening is now and again one of the Zookeeper nodes would go down, and there was a configuration setting, something to do with like startup time,
that was like basically the first line on the Zookeeper config file is how long it waits for startups.
Yeah, I think you had 5 in there or something. So that was something I found was quite important to make sure that it had enough like thinking time, because otherwise you'd wake up and find in the morning coming to work and find
had gone down.
Yeah.
So what I've noticed, and kind of potentially related to that, is that the startup time for both Zookeeper and Solr goes up significantly once you put proper index data behind it, because the files it's storing gets much bigger. So you may find, this is another thing I think you'll probably find through the kind of test the system phase of not knowing how big all the servers need to be. There's going to be a kind of a balancing point for where you should put that setting so that it waits long enough for your hardware to pull your scale of index into memory, but doesn't wait so long that it's sitting there hanging around when something is actually broken.
Yeah.
But I think it's a tuning thing.
Yeah, I think it was something that happened sort of 6 months or maybe a bit less into the project.
Once the data's grown.
Yeah, so I think that's something to make sure you monitor it and review, as you say, as the data grows.
No, I think the monitoring points are true of pretty much everything. I think that setting stuff up and making it work is quite easy. Keeping it working long term involves some extra effort. But yeah, good point. Thank you.
You mentioned about the cloud version.
Yes, Solr Cloud.
How different it is from Azure Search?
Oh, right. So Solr Cloud and Solr are basically the same search engine. The difference is the ability to scale horizontally. It is a very different business to Azure Search. As under the surface, I think Azure is probably doing very similar jobs, and scaling out instances and sharding and replicating your indexes and things. But the way they work is different, and there are some fairly noticeable technical differences between how queries work on the two systems. Yeah. So it's not easy to switch between them, but in theory, Sitecore supports both of them.
Yeah, wildcard matching on searches doesn't work the same way. So if you do like a star search, for example, on Azure Search, it isn't supported the same way.
There's a big gotcha with how many fields you can have in an index on Azure Search as well. They cap it at 1,000, which means if you have complicated indexes, you can run out of fields.
That's nice. The other question, probably not on Solr one, so I'll pick that later. You said you automated developer environment?
Yes.
So, you use some tool or?
It's just I did it in pure PowerShell. I'll grab me afterwards and I'll point you at the blog post. Anyone else? No? Thank you very much, everyone.
Okay.